Okay. Surface area and the volume of solids. With the aid of, this is a question that we can answer with the aid of our mathematical table, because it has formula for almost all the solids that we know. So what are the common solids that we discussed here? The first one is a cube. For a cube, we have a formula for volume and a formula for surface area. For volume, a cube is side times side times side. For surface area, it is 6 times side times side. Because the cube has 6 faces and they are all equal. Next is a cuboid. Cuboid is length times width times height. For the surface area, it is 3. It is 2 into length times width plus 2 into length times height plus 2 into width times height. I think there are 6 faces and each of the 2 sides are equal. I may not exhaust everything. We have a cylinder. We should know how to find the volume. Volume of a cylinder is equal to pi r squared h, and of which we know how to find the surface area. Surface area, it is 2 pi r h plus pi r squared times 2. They are 2 top and bottom. Then we have prisms. A prism is a solid with the uniform cross-section area. How to find volume? It is cross-section area times height or times the length. It depends how it is behaving. And surface area, it will be the 2 times the area of the cross-section plus the sum. Let's just not restrict ourselves. Say that the surface area, it is the sum of areas of all faces. You look for all faces and you find the sum of every face. After prisms, we go to the ones that are like cone. How do you find the volume of a cone? Is a third base area, which is pi r squared h, and that one is for pi r squared plus pi r l. That is the curved surface plus the surface of the base, area of the base. We have pyramid. It's good to know that the pyramids are named after the shape of the base. If the base is rectangular, we say it is a rectangular pyramid. It is a square, we say square-based pyramid. If it is a triangular, we say triangular-based pyramid. So how to find the volume is a third base area times height. And then it is the area of the base plus we say it is the sum of all areas of all faces. And that's for the surface area. Then after pyramids, we cut a cone, we cut a pyramid, we come up with a frustum. frustum, how do you find the area, so volume of a frustum? A third pi r squared h minus a third pi r squared h. That's the volume of the bigger cone minus volume of the smaller cone. For frustum, we also say it is the sum of all faces. We want to see one. We have a sphere. For sphere, we have the surface area, which is 4 pi r squared. Oh, no, volume. This column is for volume. Volume of a sphere is 4 over 3 pi r cubed. You don't have to cram all this, you can know, but you can confirm from your mathematical table. Try to, as you revise, try to see how a mathematical table can help you to answer these questions. Then volume of surface area, it is 4 pi r squared. Then we have numbers. We have the hemisphere. It is a half of this, so it is a half times 4 over 3 pi r squared cubed. We go to the basics. So we have a half times pi 4 pi r squared plus pi r squared. That is, we try to be realistic as much as you can. And from there, what we have is combined solid. Combined solid, it is the one that is built consisting of 2 or more solids. So that now it is combining hemisphere, combining a cylinder, and the top is combining a cone or a frustum. So it's a combination of some solids. So we can now get a number of we see this one. We also work, it is the sum of volumes of all of the solids in that combined thing. And this one for the surface area, it is also the sum of visible area of visible faces. We don't want the invisible, the ones which are fused. We want to see the ones, if painting is done, which faces are likely to be painted. If this solid is immersed in water, which surface is going to be to get in touch with water. So we don't include the invisible faces, we include all the visible faces. So this is what these are the salts that we are going to interact with. And then now, the last idea is that let us all be very realistic as you handle whichever solid. Don't come with some fixed mind that I know hemisphere, this is how it behaves. Try to analyze and see the hemisphere, it has which behavior. Anything somebody wants to add, or something you want clarity, or you want to make some correction from what I have illustrated, you are welcome. Anybody want to add something, or something that is not making very clear sense to you? Oh, these are the salts that we have. So let's get back and maybe analyze one question. Let's say we're back. Surface area and the common surface area, the volume. We have trial paper 1, question 21. Let's see how it is behaving. Trial paper 1, question 21. Okay. Question 21. This one is it is still a question. Let us see how it is behaving. Well, Brenda, read the question.
The figure below represents the cross-section of a tunnel. The cross-section is in the form of a major segment of a circle. M is the midpoint of AB and CM is perpendicular to AB. Given that AB is equals to CM is equals to 8, calculate the volume of the tunnel if it is 15 centimeters long.
The tunnel is 15 centimeter long. This is what the tunnel is. So we are told that this is a major segment, meaning M is not the center. The center will be somewhere. It is not at M. M is the midpoint. If we let the radius of this circle to be R, the length on this side is R. So what will remain is 8 minus R as the distance OM. So the distance from center to M is 8 minus R. If that's the case, we have a right-angled triangle of this kind. If I extract one, this one will be 4 because the distance AB is equals to CM is equals to 8. And if it is perpendicular, so M is the midpoint, so it divides this side to 4 centimeters, 4 centimeters. We try to analyze the situation as it is. And this side is R8 minus R. And this one is R. So with this one, we can work out for the radius of the circle. So our intention is to get the radius of the circle. So the analysis we are doing is that this is a major segment. So it means there is a center for this circle. And from the center to whichever part, from center to C, center to B, center to A, it is radius, so it is R. So using Pythagoras theorem, we can say that 4 squared plus 8 minus R squared is equals to radius squared. If we evaluate this one, it becomes 16 minus 64. Include this plus 64 minus 16R. Don't be scared. You can expand at your own rate. Plus R squared it is equals to radius squared. I know if I expand 8 minus r, it is 8 minus r squared. It is the same as 8 minus r times 8 minus r. Expanding this one quadratically, it gives us this one. I hope that there's nobody who is going to do this joke. Expanding 8 minus r squared, we get 64 minus r squared. This is the grandfather of all jokes. So let's expand quadratically. If we add, this one becomes 16 plus 64 is 80 minus 16r. This r and this r will cancel. If we take them to the other side, equals to 0. Take this one to the other side, 16r is equals to 80, and r is equals to 5 centimeters. So we have now worked out for the radius. The question has 10 marks, so you are likely to do a lot. So the radius is 5 centimeters. This one is 15, and the radius is 5 centimeters. So with this radius now, we can go ahead and find the volume of the tunnel. This tunnel is in the form of a prism. It is a prism because it has a uniform cross-section area. It's a prism, and we have the radius as 5 centimeters. So what can we do to find there? Our radius is 5 centimeters. And this one is r is 5. 8 minus 5, 3. This one is 4, and this one is 4. So let's now find the volume of this thing is we need to find the cross-section area, then you multiply by the length. So what is the cross-section area? Area of the cross-section is area of a segment, major segment. The area of major segment, normally we work it out as the area of this major segment plus the area of the triangle. Let us find the angle at the center. So we have this circle. Let me exaggerate it a bit. And then we have this one. We have 5 centimeters, 5 centimeters. This is the center. This distance is 3. And this one is 4, then 4. Let's find this angle at the center. Which angle is here? If we use trigonometry that we discussed yesterday, trigonometry says that let us choose, we want this angle theta. So angle theta, 4 is opposite and 5 is hypotenuse. So we say sine theta is equal to opposite over hypotenuse. So theta will be equal to what? Fellow Kenyans, give me the value of theta. Theta inverse. Wewe Brenda, uko na calculator? Lydia Njogu, can you see your hand is up?
53.113.
3 point?
53.13.
53.13. And that is theta, which is equals to the other theta. We multiply this one by 2. The justification is this is 53, and this side is also 53. So to multiply this one by 2, it gives us a theta which is 106.26. Is that true, Lydia?
Yes.
So now that we have this angle, what will be the angle for at the center for the major segment? That is the angle at the center for the minor segment. So the major segment will be 360 minus 106.26. So the angle we are using is 360 minus 106.26, which gives us 253.74 degrees. So this is the angle that is 253.74 that we are using to find the area of this cross section, area of this sector. So we work out for the area of a sector, which is theta over 360 times pi r squared. So our theta is 253.74 over 360 times 22/7 times radius squared, 5 squared. What do you get? Either you are now our calculator.
55.379.
55.379.
379.
So 738.
Yes.
So with this one, this is the area of the sector. This area. The area of the sector, the one I've given another shading. So, but we want now the area of the whole segment. So we need to add the area of the triangle. Area of the triangle is this half AB sine theta times 5 times 5 sine 106.7.26. Okay. So we add the two. Lydia, what do you get?
What is this after 106?
After 106 is 0.26.
Oh. Without adding is 133.0.
Without adding?
133.0. 132.
Hiyo ni kubwa sana, hebu chunguza vizuri. This is not 55, it is 2.5 times it should be 12 point something.
2.5 times 5.
2.5 times 5 sine 106.26. You have something like this, if you are confirming square centimeters. So we have the uniform cross-section area, which we have worked out, and we have 67.38. The length is 15. Now the volume for the tunnel will be equals to cross-section area times length. Our cross-section area is 67.38 times the length of 15. So we have our final answer.
10.7.
Anybody wants a question? Cubic centimeters. Well, the question is throwing us through many aspects, but that's what we should get. Now, what have we done? We are told that the figure below represents a cross-section of a tunnel. The cross-section is in form of a measure segment of a circle. M is the midpoint of AB, and the CM is perpendicular to AB. Given that AB is equals to CM is equals to 8 centimeters, calculate the volume of the tunnel if it is 15 centimeters long. We start by getting the cross-section area by getting the radius. Tukasema if this is the tunnel, the center must be somewhere. So from the center to B to A, and from center to B, it gives us the radius R. And then we have the center. So we worked out for the radius. To work out for the radius, we extracted this right angle triangle, where we have this one as radius. What will remain is 8 minus R. So we extracted this right angle triangle. Using Pythagoras theorem, the sum of the squares of the two shorter sides gives us the square of the larger side. So 4 squared, and this one gives us R squared. Expand, we get radius squared and radius squared cancelling each other. So you remain with 8 minus 16 R is equals to 0. And 16 R is equals to 80. So radius is equals to 5. So you have worked out for the radius. After you have the radius as 5 and 5, so and the center, this one becomes 3, this is 4, this is 4. So we can now work out for the area of the measure segment. How do you find the area of the measure segment? It is the area of the measure sector minus area plus area of the triangle. So to work out for the area of the sector, you need an angle. So we extracted a right angle triangle, and we said if this is our theta, opposite side will be 4, hypotenuse is 5. So we use the sign. Sin theta equals to 4 over 5. Sin inverse 53.13 times 2, because we have two angles of this kind, 106.26. We don't want 106.26. We want the reflex angle, the angle which is subtending the sector. 360 minus 106.26. We get the answer. 253.74. Area of a sector, theta over 360 pi R squared. Substitute 253.74 over 360 times 22 over 7 times 5 squared. We have 55.38. That is the area of the sector. Now we need the area of the triangle. Area of triangle, we use the formula a half AB sin theta. So a half times 5 times 5, angle between the two radius is 106.26. So we have 12. We get 12. After 12, you add the 255.38 plus 12, 67.38. This is, since it is a prism, area volume of the prism equals to cross-section area times length. And our cross-section area is 67.38 times 15. And now our final volume is 1010.7 cubic centimeters, period. That is the equation. Anybody was a question here? Lydia, do not lower your hand. Okay, we go to another question. Trial 5, paper 1, question 15. Trial 5, paper 1, question 15. A triangle ABC is such that AB is 12 centimeters and AC is 17 centimeters. If its area is 512, find the size of an angle. That one does not lie in what we want. That's the area of plane figures. Trial 6, paper 1, question 13. That's the area of a plane figure. Hatutaki hiyo. Trial 6, paper 1, question 17. Let's work out question 18. I want you to try question 18. I want to see how question 18 is. A frustum with a regular pentagonal base is such that its top is of side 12 centimeters and the bottom is of side 24 centimeters. If its perpendicular height is 20, calculate the length of the slant edge and the volume of the frustum. A frustum with a regular pentagonal base. It's becoming tricky. A pyramid that is of pentagonal base. So the base has 5 sides, which are regular. Its top has 12 centimeters, and its bottom side is 24 centimeters. If its perpendicular height is from the middle to the middle, it is 20 centimeters. Calculate the length of the slant edge. And then the volume of the frustum. Let me go with the analysis of the mind. We may not script it so much. If the base is we use similarity and enlargement. If this one is 24, its thing is cut somewhere, which is 12, to give us a frustum. It's not behaving very well, but let me force it to give us something like a trapezia, a pyramid. Initially, it was a pyramid. Now, after cutting this pyramid, we get this. After cutting this pyramid, that's when we get the frustum. So if this is 12, 12, 12, 12, 24, 24, 24, 24, because it is regular, all sides are equal. And then the height is 20. So using similarity and enlargement, we can say that 24 over 12, it is equals to, if we let this one to be the height, is equals to, it is equals to h plus 20 over h. We let the height of the pyramid that was cut off to be h. So, and the remaining height of the frustum is 20. So 24 over 12, the ratio of corresponding sides should give us a constant, will be equals to h plus 20, the whole of this one, which is a h plus 20. And then now we use that one to find the height. So cross multiply 24h is equals to 12h plus 240. This one to this side, 12h is equals to 240. 20 times 12, I think into 40. So h is equals to 10. So the capital H is equals to 30. That's what we can see. What we are working out is for us to find the length of the slant edge. There are so many approaches. So if I extract one right angle triangle from here to this, the bottom, and then the diagonal. Diagonal is not the case here. Things are tricky. Let me not engage myself to the diagonal because this is not a, it is a pentagon. Able try to draw something that has 5 sides which are equal. We want the center. How do you find the center? This one is 24, this one is 24, this one is 24, and this is 24. We need the center. So we can join to the center and we can find this length. This length, if we drop a perpendicular, we are going to get 12 here and we get another 12. And what we want is I want the length from the one that is in bold, or I want this length. We can find the angle at the center. This angle can be easily worked out. 360 divided by 5. 360 divided by 5.
72.
72. So if 72 is divided by 2, we get 36. So this angle here will be 36. The whole of it is 72. This one will also be 36. So to get this distance, it will be opposite is 12. The angle is 36. Now this one becomes the hypotenuse h. So we use sine. Sine 36, this equals to opposite, which is 12, over the hypotenuse that we don't know. So hypotenuse would be equals to 12 over sine 36. $20.4. So 20.4, it is all over. 20.4, 20.4, 20.4. Now let's get back. We want the slant edge. Let's get back to our diagram. So from the center to one of these vertex is 20.4. Okay, what we have done, we wanted to find we are looking for this, for the slant edge. The slant edge of the frustum. And for us to find the slant edge, we need the 20.4, so that we find all of this one. And then we use maybe similarity enlargement or whatever. Then we find the slant edge of the pyramid of the frustum. So let's extract. Hapa tumepata ni 20.4. The whole height is 30. We can now easily find this using Pythagoras theorem. We can find the whole of this height. And the whole of this height will be the capital L, the whole of this one, call it capital L, squared is equal to 20.4 squared plus 30 squared. Then now to get L, you find the square root and find the square root. What do you get?
36.27.
36.27. 0.27. So the whole of this one is 36.27. But we don't want all of it. We want the one that I'm going to highlight here. We want this one. So we can use similarity and enlargement, where we say L, capital L over small l, is equals to the capital H over small h. Our capital L is 36.27 over small that we don't know is equals to the capital H, which is 30, over the small h, which is small h ilikuwa 10 ama nini?
20.
Ilikuwa 20. Are you sure? Let's get back. Kuna mahali tulitafuta the small h. Oh, ni 20. It was 240 divided by 20. Then this one is also not correct. This is not 30. The capital H is not 30. It is 20 plus 20, which is 40. Sindio?
Yes.
So we change everything. This one is also 40. And this one, we change it to 40. We are correcting everything. So it will not be now 36. Somebody work out. It will be
44.90.
44.90. So we have 44.90 equals to the capital H, which is 40, over the small h, which is 20. So cross multiply, we get L. Small l will be equals to what? .9 times 20 divided by 40. 22.45. Is that true?
Yes.
So now we want the slant height, the one that I've highlighted in yellow. It would be equals to 44.90 minus 22.45, which is gives us 22.45. So the slant height of the length of the slant edge is 22.45. That is the length of the slant edge. I don't know the navigation, but maybe you fall later and see how we managed. Volume is now the easiest thing because already we know the perpendicular height. Volume of our frustum, we said, is equals to volume is equals to base area, a third, base area times height, minus a third, base area times height. Our base area we start with the complete pyramid, complete pentagonal pyramid. The area of the base. How do you find the area of the base? Let's do the analysis. If we have this one as our, we said the angle at the center is what? 72. 360 divided by 5 is 72. So we find the area of one, then we multiply by what? we multiply by 5. This one gave us 20.4, if you remember, 20.4, and the area is, so the cross-section area will be equals to, tulitafuta kutoka hapa. So the cross-section area of the base, not cross-section area of the base, which is a pentagon, is equals to a half times 20.4 times 20.4 sine 72. What do you get? And then you multiply it by 5. Yes, Lydia? You multiply by 5?
989.48.
1?
988.48.
988.48. All right. Just a minute. Mm-hmm. Okay, we get back. What is the, okay, we were here finding the area of this base. We have said it's the area of one triangle times 5. Area of one triangle is a half AB sine theta. A half times 20.4 times 20.4 sine 72. Then times 5, which we have been given as 988.48. That is the area of the base. Is that true?
989.48.
989.
Yes.
989.48. That's the area of the base. Now we have another area of the top. This one. We need the area of the base, so that we multiply by the complete height and the area of the top. So area of the top, we move there. Let's analyze the top and let's see how it is behaving. Area of the top, we have another pentagon of these 5 sides. Still the angle remains to be 72. But on this side, we have 12. So divided by 2, we get 6 and 6. We have a right angle triangle. This one is 36. The angle is 36 at the center. So opposite is 6, and the opposite is 6, and the hypotenuse we don't know. So we use sine. Sine 36 is equals to opposite over hypotenuse. So hypotenuse will be equals to 6 over sine 36. What do you get? 10.2? 10.1. It should be something like 10.2. 10 point?
10.
10 point what?
2.
2.1, eh? So approximately we can say 10.2.
Yes.
Yes, let's work with 10.2. So once we have 10.2, we need the area. So it is the area of one triangle times 5. So the area would be equals to 5 into a half times 10.2 times 10.2, then sine 72. The whole of this angle is 72. So what do you get?
$247.37.
247.37.
Yeah.
All right. Now we can launch the volume. Volume of this frustum will be equals to the volume of the bigger pyramid minus volume of the smaller pyramid that was cut off. So we work on getting the volume of the bigger pyramid, which will be equals to, so volume will be equals to a third times the base. The base area, the first one is 989.48 times the complete height, which was 40, minus volume of the smaller cone, the smaller pyramid that was cut off, a third, times the volume we have worked out, 247.37, times the height, which is 20. And then we can now find the volume. So it is a little bit involving, but that's what we are expected to do. So what should guide you is the, how do you find the volume of a frustum? The bigger pyramid minus the smaller pyramid. So we find now the volume. We can launch this one from your end after working out. Later you can, I'm going to share this link. You can follow through and see any clarity. Then meeting tomorrow, you can raise questions. I want now to give you one question that you try. You try trial paper, trial 4, paper 1, question 19. Let us check on that one. Let us have a sequence. Trial 4, paper 119. Yes, I want you to work out this question. Oh, this is 20. Is 20. Trial 4, paper 1, question 9, question 20. I'll give you 5 minutes to try this.
Kisha nimepata answer ya A kama 36.62.4 liters.
Answer ya A
3662.4 liters.
hivyo. That's good. Another person? Another person with another answer?
Chami nimepata
9.42 liters.
9.42 liters. Another person with something else? Okay, let's confirm and we debate and see whether we are on the right track. The figure below shows a bucket of depth 30 centimeters, which is used to fill a cylindrical tank of radius 1.2 meters and a height 1.35 meters, which is initially 350 full of water. Calculate capacity of the bucket in liters. Hapo ndio tuko. The bucket is has a depth of 30 centimeter to fill a cylindrical tank of 1.2 and a height 1.35, which is initially 350 full of water. The capacity of the bucket in liters. Something is not adding up. How did you work out? We don't know the radius. We don't know the slant height. We want the capacity of the bucket in liters. And we are not even told how many times. How did you work out? For me, I see like some gaps. Yes.
Kutafuta volume kwanza. Nilifanya volume is equals to pi r squared height. Sasa nikachukua radius kama 1.2 meters.
The question has some
hatuna pi.
Some mishaps, Let me check from the answer so that we can draw the. It is tulisema ni gani? Tulisema ni paper works. Trial paper 4 question 20. Trial 4 question 20. Sawa. Marking scheme trial 4 question 20. So question 20. The radius is 20 and 15. That's when it can be worked out. The capital radius, and this one is now the one which is 30. The question was not, we are not given the radius of the base and radius of the bigger radius and small radius. Now with this one, it can be worked out. Otherwise, haingefanyika. So, the capacity of the buckets, we find the volume of the bucket. Similarity and enlargement 20 over 15 is equals to H plus 30 over H. 20H is equals to, this one is very common concept. 20H is equals to 15H. Plus 450. 15 times 30. 5H is equals to 450. So H is equals to 90. Capital H 120. So immediately you get the small h, state the capital H. That is, if we complete this diagram, this is our small h. And now volume will be equals to a third pi r squared 22 over 7 times r squared 20 times the height 120 minus a third times 22 over 7 times 15 squared times 90, and then we get the answer in cubic centimeters. What is the answer? Yeah, those with calculators, you're not communicating.
$29,071.43.
20?
29,071.43.
0.43.
Eh. .28. Eh.
Okay. This one is cubic centimeters, eh? But the question is asking capacity. Capacity should be either in liters or multiples or submultiples of liters divided by 1,000. So 29.071 liters. 1 liter is equivalent to 1,000 cubic centimeters. So we have answered part A. Part B, the volume of water required to fill the tank in full. Initially, the tank was 350 full of water. So if 350 full of water, 350, so what is remaining is 250. A cylindrical tank of radius 1.2 meters. So we want to, it is 350 full. So what is missing to completely fill the tank is 2/5 of the tank. So 2/5 times pi r squared h, 22/7 times 1.2 squared times height. And the height of the tank is 1.35. So the volume of water required to fill the tank in liters, it is 2/5 times the capacity, the volume of the tank.
2.443.
2.4
43.
43 cubic meters. We are not told in which, in liters, so times 1,000. Is it 1,000? 1 cubic meter equivalent to 1,000 liters. Yes, it is. Now it becomes 2 times 1,000, 2,043. It's for 30. Multiply by 1,000. 3430 liters.
Cha niulize swali.
Yes.
Let's say the previous answer umepata in many decimals. Unafaa kuandika in 4 ama unaweza andika in any?
We advise you consistently work with the 4 significant figures.
So itakuwa 2.4438.
38,
Sawa.
4 significant figures, it is what we consider as accurate. Part C, calculate the number of buckets that must be drawn to fill the tank. Number of buckets. Number of buckets will be equal to the volume to be filled divided by the volume of 1 bucket. Volume of 1 bucket is 29.071. And those are, then you round off. So how many buckets are there? Calculate the number of buckets that must be drawn to fill the tank. So 24, 38.
84.
Exactly 84.
83.86.
Yeah, you can round off. You get 84 buckets. That's it. This is the area that, let us now look for the one that has combined the solid. I'm looking for specifically the question that has combined solid. Hope we get one. Something like this. Yes, I want you to try this one. Combined solid.
Mm. Sharudisha swali kwa screen. Sharudisha swali kwa screen.
Yes. Bring the part B.
Mshafanya part A.
Part A tumefanya. Okay, part A ndio hiyo. On my screen.
Sio ni screen yako.
Yeah. Let me check whether it is imeonekana?
Yes.
Imeshinda ikiwa hivyo ama ni saa ngapi ilipotea?
Cha peleka juu kidogo. Juu.
Hivyo. Well, we have been working minus the screen.
Yes.
Since we started the lesson.
No. Hii swali peke yake.
Hii peke yake sawa.
Yeah.
I give you how many minutes to clear this question?
Try you repeat the steps for us.
The section part A.
Yes.
Okay. Part A. Like the first question we worked out, we said this is a pentagon. For a pentagon, we said we can divide this one into 5 equal triangles. The angle at the center is 360 divided by 5, 72. If we drop a perpendicular, this one would be 36, and it will be 36. And the whole of this one has, from the equation, the side is 6, so this one would be 3, 3. Considering 36, this is an opposite, and this is a hypotenuse. So saying sine 36 is equals to opposite 3 over hypotenuse h. So h is equals to 3 over sine 36. Working out 3 over sine 36, it gives us 5.1. H becomes 5.1 with our calculators. So this is 5.1 and 5.1. So area of the pentagon, it is equals to 5, because they have 5 triangles, 1, 2, 3, 4, 5, times the area of one triangle, I have AB sine theta, times 5.1 times 5.1 sine 72. Our angle here is 72. And this one gives us 61.84. Are we in agreement?
Yes.
Now I want you to attempt part B. B, which is saying calculate the total volume of the solid, volume of this and the volume of the base. Then I'm waiting for the responses. All right. What's the response to part B?
4,931.7.
Part C? Because of time, these are the responses to the questions. For total volume, we have part A. We started from here. Our answer was closely to this one, 61.884. Our ametumia tan, sisi tukatumia sign, so there is a slight difference. Volume for the cylinder 4,312. That's what you said you are Ngash had this one. But now total volume, we add the two. Total volume with the volume of the cylinder plus the volume of the pentagonal prism. 61, which is the cross-section area, times 20, 5,550.7. Part C, we use the LSF, linear scale factor. Then we work out to find the volume scale factor. After volume scale factor, we equate the two and get 44.41 cubic meters. Basically, that's what is expected of us. Measurement, surface area, and volume, it is very significant in our exam. I wish that we stop at that level, find other questions, and then you work out. Yes?
Volume of cylinder I'm multiplied by 7.
Volume of a cylinder.
22 over 7 times 14 times 14 times 7.
Yes, 7 is the height of, let's check. What is the height of the... The height is supposed to be 6.
Yes.
Sure. It should be 6. Our marking scheme is wrong there. The height should be 6, huh? Work with the 6. So this one should be 6 times 6, not 7. Good observation. Let's stop there. I wish you well. Let's meet tomorrow and do something else. I gave you the link that has the recorded sessions. I would upload this one as well. Somebody who missed it can go through and maybe check. Wish you well. Have a nice day. Bye.
Bye.
Bye.